So today my goal is to talk to you guys about HTTP communication on the client. Okay, it's a simple enough topic. The more difficult topic will be how we transform our application architecture into a reactive one. Okay, that's I think it's the hardest part of this. But for now, let's just focus on making HTTP requests. Okay, most of you are going to build a client application for your web API, which will be built in another course. So this will go directly towards those who are in need of this for the moment. Good morning, Christ. Yes, hello, Jesus. Hallelujah. Okay, so let's continue. Okay, Jesus is here. We're all good. Okay, first and foremost, I'm going to use a third-party web API, okay, for fetching jokes. I am going to use Icanha's dead jokes, okay, this. So when I make a request, an HTTP request, asking for a JSON answer, I get this back, okay? So this is using curl. If I use a browser, I will get an HTML web page. In this case, I'm getting a JSON request, a response. Okay, I am going to use this site, but of course you will be using your own. Mind that by default in Android, there's no HTTP requests are not allowed, meaning that we must use HTTPS, okay, secure channels. Okay, so if you guys want to test using your own API, I will in a moment talk to you guys about that. So either you deploy it or you use something that gives you access to an HTTPS endpoint. Okay. There are other ways, of course, which is turning off this this verification, but I don't think it's a good idea, so I will not talk to you about that. Okay, I will not show you how to turn it off. Okay, because it's not a good idea. Again, let's then start by first and foremost, what tools am I using here? Okay, I am using I think okay, it's good. We can see it. Yeah, I'm using KTOR client. It's a library. Okay, a multi-platform library, Kotlin library, to make HTTP requests. Okay, it's not complicated to use, so I will show you in a minute. But for now, I just want to focus on the dependency, and the dependency is here. Remember that the dependency is this one, core. Okay, this is the library. Oh, by the way, remember that all my dependencies in this project are expressed through a version directory, meaning this TOML here. Okay, keep that in mind. If you guys want to copy my dependencies, you must make sure that you add these entries to this directory of versions. Okay, the TOML file. Okay, so bearing that in mind, I've added the core dependency, which is the library for issuing HTTP requests. Then I'm using two other dependencies. The first one is the actual engine used to make the requests. KTOR client is an umbrella library which can use different HTTP engines. Okay, in this case I am using OKHTTP. Okay, and this one. Do you guys know what is content negotiation? Ever heard of it in HTTP? Some of you have. Content negotiation is about the client stating what he prefers, what he wants. It's around accept headers and content type response headers. Okay, it's about the client stating, like I have done here, look, I would like to have a JSON response. Okay, JSON encoded response. This is content negotiation. It's in its simplest form. Okay, so again, another dependency for supporting content negotiation, and finally serialization. Okay, so you guys can use this set of dependencies to issue HTTP requests. Another important point is this. In the manifest, do you remember what I've told you about the manifest? The manifest is about declaring the payload. It's about declaring properties or requirements of the application. Namely, it states its payload, its components, and it states its requirements in terms of permissions. These two requirements, I had to add them, okay? This application requires internet access and, by the way, and now also access to network state, okay? I added these two entries to my manifest to declare that the application requires those permissions, okay? And I think that's it for the most part regarding setup. Changes in my setup, I think. I haven't forgot anything. Yeah. So then what have I done? I will talk to you guys later on about the tests. Let me just close this and also this. Okay. Then what have I done? Well, I have this abstraction. Remember the abstraction? Joke service, which I have implemented in a fake way, like so. Well, now I have an actual implementation of the joke service. Let's see it running, okay? Let's see it running. So this is the jokes demo. Oh, by the way, I'm adding mm, okay, let's see what's happening. Okay, so let's continue to see. I have the joke service here. I have the implementation of the joke service, two implementations, the fake one and the real one, using Icanha's dead jokes. The real one is like this, okay? I will try to figure out what's going on with my demo. And the implementation is like this. I have the URL, I receive the HTTP client, which is an artifact required to perform HTTP requests using this library, okay? And then I do this. Get in this library to express what we want, what kind of request we want. We use dot, post, get, put, as you can see, okay? In this case, I'm using get. I state the URL source, and then in this lambda, I build the actual request. In this case, building the request is merely adding the header accept to it, requesting for an application JSON response, okay? And then I do this. I get the body interpreted as a joke DTO. What is this, the joke DTO? The joke has an external representation, right? Like so, an ID, which is a string, the actual joke, which is another string, and finally a status code, which is an integer, okay, number. So this is the DTO. This is what the server produces, returns, okay, and its reply. I will have a data type that corresponds to this, okay? When you are in DAW, in DAW, this is called the output model. In our case, we are the client. This is the input model. Okay, so this is a data transfer object. I have created that data transfer object, which is this one. Okay, which is comprised of an ID, the joke, and the status code. Simple as that. Then once I have the request here, I state, look, I want the body to be, I'm expecting the body to be a joke DTO, okay? Capable of being transformed into an instance of this. How is this done? Using serialization, Kotlin serialization, okay? Which by default serializes using a name convention. There's an ID, there's a joke, and there's a status. If by any chance the names don't match, this will fail. I will have to configure it accordingly, okay? So in this case, for simplicity, I've used exactly the same names, okay? Then I convert this DTO to my domain type, which is the joke, where I don't care about the ID, so I drop it. And also I don't care about the status code, so I also drop it, okay? So this actually fetch joke returns the joke, domain type, converted from a joke DTO, which is the detail of the implementation of this service. You guys got that? Yeah? Simple enough? Cool. And that's it. This is the actual implementation of my service, the real service, okay? Then I have what I had before. I have the joke of the screen view model, which launch. This is why it's taking too long. It's 30 seconds. Okay, a bit too long. So every 5 seconds, yeah, every 5 seconds we will fetch it. Okay, so this is what we had. I'm just going to show you guys so you remember what we were building. So here we have the joke of the screen view model. Again, the screen view model has immutable state of screen state. Okay, it starts idle. Okay, then once the view model starts, it launches a coroutine which forever, until this scope is cancelled, just checks whether it's not loading, makes another request, waits for a while, and keeps on doing that, okay? And the internal fetch joke, it's simple enough. We just fetch the joke, and if it all goes well, it displays success, otherwise it displays an error, okay? And that's it. I'm expecting this to work. Let me just try to understand what happened here. I don't understand why this is not working. Okay, jokes demo. I'll have to instrument it. This is taking too long. Why is that? Okay, this is something about the emulator, which I forgot. Apparently, we need to have the Wi-Fi connected, so we actually have network on the device. Okay, I forgot this. Let me just show you. See here? Doesn't do anything until I actually connect the Wi-Fi. Yeah, I'm not sure why, but yeah, this is the issue here. So it's taking too long again. Let me just ramp it up again. Yeah. Okay, so this is, I hope, oh, okay. So this is, I hope, enough to get you guys started on making HTTP requests to your web API. Oh, by the way, there's another thing. Where? Here? No, we don't actually. But I wanted to show what happens if we have a delay. But here we are seeing it because it doesn't move forward. I'm not getting a reply. I think that's because I don't have actually internet in the device. Yeah, I don't. And I'm not sure why. Okay. Okay. I think we're good now. It's too fast, you see. So the problem was we weren't getting Wi-Fi internet in the device. So you see, it's too fast. So I usually had it for demo purposes, a delay, a small delay, so actually you can see that the several states we go through. Okay, so that's the general idea, and that's it. Okay, so this now periodically is going to fetch it again, and yeah, so a set of jokes. Okay, so I was saying, hopefully this is enough to get you guys started making HTTP requests to your web API. There's an important aspect to bear in mind still, okay, which is this. Um, when you are issuing requests, okay, to your own web API, what is going on is that you are trying to reach from the device your own machine, okay? So this is a problem. Why is that? Because you need to use the proper IP address, right? So if you have the API deployed in the cloud, all is well. You use here the IP address of your deployment, and that's okay. But in dev time, when we are building on our own machines, how do we do this? One way to go about it is to use this. Let me just show you. Okay, look, in my case, I'm using a third-party API which is deployed. Okay, so that's not an issue. But when in development time, when you are going to build your own API, you should look into this. Set up Android emulator networking, and in particular, use this IP address. So you can reach from the emulator your local host. But remember, localhost on the emulator is the emulator itself. Okay, so if you want to reach the dev machine, you must use this IP address, which is already configured on the emulator to refer to the hosting machine, okay? The host machine of the emulator. Keep that in mind, okay? Another thing is, okay, but what about HTTPS? You can set it up, or you can use another tool, which I'm showing you here too, which is ngrok. Okay, what is ngrok? Let me just make ngrok is a tunnel. Well, it's more than that, but for our use cases, it's a tunnel. Okay, like this. Let me just. So the general idea is this. Let me just sketch something here and QuickTime Player. I'm not sure. Some of you guys already told you about this, but not all. New movie recording. Okay, let's use this. Okay. Another one. Yeah. So the idea is this. You are here in your emulator, emu. Okay. The emulator is here in your dev machine. You are running here your web API, also in your dev machine, or your colleagues, if he has a better computer. Then you are going to use ngrok to do this, to open a tunnel from this port where the web API is listening to the cloud, which then maps it to another public port, which will be used by the emulator. Okay? So requests to the emulator will be using this IP address, a public one, which you have created through a tunnel using ngrok. Okay? Get the idea? So all requests issued here will go here and replies here. Okay? This is the magic of ngrok. Okay? You can try it out. Ngrok. This tool here. Okay? It supports many other stuff, but it's free tier enables us to do this. So yeah, you can use this too. Otherwise, you simply deploy it. It's deployed using render or whatever you are going to use in DAO. And then you make requests to it. Okay? Yeah. And you have, in the meantime, while the API is not fully built, you have hybrid implementations of services, part real, part fake. Okay? For example, to accommodate the incremental nature of the API being built. But yeah, that's your choice to make. Okay, so I'm just pointing out the existing tools, and that's it. Yeah. So regarding HTTP requests, that's it. Okay. But yeah, close this. We are not done yet, right? We are not done yet. We still have the issue or the problem of we are using a pool communication model. Remember that? We are doing this. We fetch it periodically. As soon as the view model appears, we fetch it. Let me just ask you something. Imagine I'm going to run it. Imagine that I have here something like a configuration button which launches a new activity, which hides this one. Okay? Because it goes on top of this. We do start activity. My question is, what happens to this coroutine? Do you understand my question? What happens to this coroutine? If I launch another activity which hides this one. What happens to this coroutine? You understand the question? Any ideas? Hmm? No? What do you expect? What do we want? Let's start by this. What do we actually want? We want this to be running while we are displaying the jokes. If we are not displaying any joke, there's no point in executing this coroutine. We agree on that, right? There's no point. Why would we ask for a new joke, consume battery, if we are not going to do anything with it, right? So there's no point on asking it, on making the request, right? What would we want is that once the screen is no longer visible, this would stop. Yeah? Generally, we would want to make sure that there's some, if we want it, something is happening to fetch it. Otherwise, it is not, right? Generally speaking. If I'm trying to display the joke or the jokes, then we are fetching them. Otherwise, we don't fetch them. Okay? So, the general idea is this is not a good approach simply to, on the init of the view model, to start a coroutine which fetches stuff. For several reasons. One, the period. When, at which frequency we make the request. For example, for you guys, you are making a game. Which is the best frequency to make HTTP requests to figure out whether the opponent has already played or not? There's not a good frequency because we don't have any expectations regarding how long will it take to make its move. Okay? So it would be better to have that information pushed towards us. And that's exactly what we are going to start building, a push model architecture, or AKA reactive architecture, okay? Instead of pulling, we are going to build a push model architecture, okay? Push communication model architecture. Let's build it then, okay? So first and foremost, we already have, is this push or pull using this terminology? Is this push or pull? Between the view model and the UI, we have a push or a pull. Is it a reactive architecture? Why not? Let me just make another diagram. What happens between the view model and our UI? Oops. We have a view model. The view model has a mutable state, a state holder. This state is a composed construct which ensures that whenever it is changed, all compositions that have read it are remade. Recompositions occur automatically, right? Then any changes to this propagate towards the UI, and the UI updates accordingly, right? This is what's going on here. This is the current state. Whenever I write to it, the UI reacts like this, reacts by, we are reading it here, it reacts and a recomposition occurs and the when executes again. So yeah, it's already reactive. Between the view model and the UI, we already have a reactive architecture because the UI is not fetching for information periodically. It's updating whenever a change occurs here. And this is happening automatically, right? Because I wrote to it and this. So we already have a reactive application between the view model and the UI. This is clear for everyone? You understand what I'm trying to say here? Yeah? Okay. So what's wrong with this? Nothing is wrong with this. We already have a reactive application in this part of the woods, okay, of the application. We just want to have it to our right side. We want to have it in the remaining of the system. Cool, let's build it then. First and foremost, instead of having here a loop asking for stuff, what about we push that loop away from the view model? What if we could push this away from the view model? This. My glasses. So we don't want this, right? We don't want to have this loop here, okay? We want to eliminate this. Remove this auto-refresh logic. Let's start by looking at our service. This auto-refresh logic is imposed by the design of our joke service. Remember, we have a suspend function which returns a new joke. This means that the service simply returns a new joke whenever someone asks it to. What if we could have a joke service that instead of having a pull interface would have a push interface? What if? Okay, let's build it. So what is a flow? Remember, what is a flow? A flow is a sequence of elements which can be produced asynchronously. This is exactly what we want here. We want to produce a sequence of jokes that are being produced asynchronously by fetching stuff from the web API. Okay? So let's do it. So instead of having this being fetched here, I would love to, I would love to simply register my interest in it, like this. What about doing something like this? Joke service dot joke collect, like this. And whenever a new joke appears, I will do this. I will publish it here. Current state, new joke. What if, right? You understand what I'm doing here? Instead of refreshing, I simply state, look, whenever a new joke appears, put it here. Yeah? And this pushes away the need to fetch away from the view model, eventually pushing it towards the API implementation, yeah. But for now, I'm just pushing away out of the view model, saying, look, I don't want our view model to be fetching stuff periodically? Because I don't know which is the good frequency. I don't know. There's not a good frequency for polling. Okay? So because I don't know which is the good frequency, I'm just stating, look, whenever there's a new joke on the flow of jokes from the service, I want to collect that joke and put it here. So once I do this, it triggers the update of the UI, and UI updates accordingly. Yeah? Any questions? Any questions? We're good? So this is, you may be thinking, but look, what is being done here? We will look into it in a moment. For now, I'm just trying to show you guys this is a primitive that registers this code to be executed whenever a new joke appears here. Whenever a new joke appears here, this code executes and publishes that joke in the form of a success state, pushes it here. When it puts it here, what does it happen again? A recomposition occurs automatically. So the problem now is, okay, how do we build this? How do we do it? Well, for now, let's do the polling there. Let's put it in the service. Okay, why not? This means that, oops, sorry, let me just hide this for now. This means that our fake service, let's start with the fake one. Our fake service has a get, which returns what? Well, a flow builder. This returns a flow, which forever emits, I liked it, emits jokes. Yeah? What have I, is anything better now? Or are we still the same? We have a while true, right? So, is this an improvement or not? Well, by the way, let's look at this working. This is 5 seconds. Yeah, I like it. This is joke size, a random number between. Yeah, jokes index value. Yeah, emit. This is how we issue a new joke to the flow, meaning every 5 seconds there will be a new joke. And this is how we build a flow using a flow builder. The content of this expresses how the flow is built. And here I'm saying I am building a flow by forever, every 5 seconds, emitting a new joke. Yeah? As simple as this. Now, let us see this working, and I must first and foremost do this. Change this to have the fake implementation. Yeah? Let's do it. Okay? It just appears. You could say, look, this is not ideal. Why is that? Because I don't see it loading, right? It will just instantly change. Yeah, we will address that later. But yeah, it will appear another. Look, it just changed again. Okay? So I now have a reactive solution. By reactive, I mean the code reacts to changes in the data. Okay? I'm not fetching the data. I'm reacting to it. Where? Well, for now, we have it up to here. Now, we have the UI, we have the view model, and we have a service. Now, who is doing the polling? The service. No longer the view model. And this is reacting to changes on the data. Okay? What? Is this better or not? And why? You see what we are aiming to? Now the service is doing the polling. We don't have the view model doing the polling anymore. Is this better or not? Well, for one part, all of this code is not dependent of a cycle, a period of requests. Only the service is dependent now. And tomorrow, I mean, eventually, you will add support to this to your own web API, meaning that the service itself will no longer also be doing poll requests with a frequency. Okay? How is that? You will be using server sent events. Server sent events, SSE. Okay? And then there will be no polling at all because there will be a connection. This is your web API. There will be a connection towards here, and the web API will push information, and all of this will be reactive, end to end. Okay? But in the meantime, while we don't have this, well, at least our neck of the woods, our part of the solution, is already reactive, is already prepared for a full reactive application. Okay? This is the overall structure of the applications which use instant messaging and which we see to immediately pop up something on the client side. Okay? It's using this kind of approaches, reactive solutions. Okay? So, in Kotlin, it's using flows. One final element here. So, we already have, it's updating, gladly updating. Let's see another thing here, which is we start with a flow of jokes, but we transform that flow of jokes into a mutable state of. Well, there's no reason to use a mutable state here. We only need mutable states in the UI. Okay, this is an artifact of compose. We could also use a flow here. Okay, so let's build this using a flow. The flow var let's use this current state flow. This is a mutable state flow of okay. And like so. The general idea is exactly the same. So my intent here is to, instead of using a mutable state, which is an element of compose, use a more general one, flows. Okay? And in this case, I'm going to use a flow. So I can publish this to any other component that wishes to be reactive to that change, to changes on that data. Otherwise, this would be restricted to compose only. Okay, you see, so this mutable state only produces reactive behavior if we are dealing with a compose UI. But what if there's something else outside of the view model? For example, a legacy view. You see, legacy views are not built in compose. So we will use a flow here too. A mutable state flow. What is a state flow? A state flow is a state holder that behaves as a flow. As simple as this, okay? It has exactly the same primitives, but it's a state holder. So here, I'm going to use on my client, on my UI, instead of doing this current state flow, collect as flow, as state. Okay? So this, bye. Okay? Okay, guys. So, what have I done? Prior, I had mutable state. Mutable state is specific to compose. I want to continue to have a reactive solution, but I want the view model to be more broader than to be used by compose. Therefore, I'm going to use a state flow. Okay? To use it here, current state dot value is a delegated property. So current state, let me just understand what's going on here. Yeah. Because I'm using delegation. Okay, no problem. I'm not using delegation anymore. Value, and now this is the, okay, cool. He was complaining here because he could not have a smart cast due to being a delegated property. Okay? So here I am again consuming the data, collecting it as a mutable state, and I make decisions according to that. Okay? Same as now I use a collect as state. Okay? Let me just leave it here. Like so, like so. Okay? But now a flow. Finally, we need to, instead of writing here to this, we want to write to here. So it's not this, it's this. Okay? Current state flow, sorry. Yeah, so I put it here, current state flow. This is simpler to just comment this out. I will leave it here for now so you can look at the differences, okay? But later on, I will remove it. Value, 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 and this is it. Dot value is, okay? So this is mostly the same, but with an important difference regarding flexibility. This now is not specific to compose. It's more broader than that, okay? It can be used wherever. I can use flows. So let's run it and see whether this is going as we want. Again, let me remove this. And let's run it. Jokes demo. Here you have it, okay? How many of you guys have already tried to build something that displays information, for example, on your screens using using the create lobby or the lobbies? For example, you are on the lobby screen, right? There's a list of lobbies. You press one of them, you go back, and it's not updated. Any of you already bumped into this? That the UI is not updated once we navigate back to the screen that displays information? You haven't thought of it yet, but it's a common problem. We are displaying some information, we go and watch the detail of some part of it, we come back, and once we come back, that UI is displaying stale data. The data is no longer updated. It's a common problem. We need to address it because we want to see the most updated information possible, right? So what is a common solution is to, whenever the activity displays itself again on restart, we fetch the data again. Not with this, okay? Because this reacts, this updates it naturally, okay? So although there's a bigger cognitive load, we have something in return, okay? Less amount of code, okay? I hope this helps. So finally, and I will close it after this, I'm not sure whether this is overwhelming or just very simple. I'm not sure. I'm trying to read in your eyes, but I have many different reactions. How many of you have already done concurrent programming? So this is very simple, right? It's simple. It's complicated. You abstain yourself from voting, right? Okay. Well, the general idea is to, instead of having to fetch the data, and believe me, there's a lot of concern regarding when do I need to actually fetch it again. Instead of building applications this way, I am building the application by constructing the pipeline that reacts to changes in the data. Okay, this is what we are doing here. Look, we have the screen. The screen states, I want to react to changes in this data by displaying a new view. This is building the reaction pipeline. And then on the view model, I am stating, look, I want to react to changes on this data by publishing the new value here. Okay, and for now, here we are stating, look, we build this joke by fetching it periodically, but this will change in the future. You will have here, look, I want to react to changes in the data sent by the server by publishing it here. Okay? So this will change in the future by having server sent events. Implementation here. Okay? On the real service, of course. This is the fake one. By the way, here on the real, you can use that jokes. This API does not support server sent events. And I am trying to build a reactive application. What can I do here? Okay, well, I can build this. This is a flow which periodically fetches the joke. Cool. We do this. Emit. Well, I like this. Emit fetch joke. Yeah. Here it is. 5 seconds, whatever. Now, the service, every 5 seconds fetches a new joke. Okay? Let me put here 10 seconds, just in case. It's too fast. Oh, I must change it again. And I will end by noting something. Let me just change this here again and put the actual real one, which now fetches from the server. Jokes demo. Ten seconds is too long, okay, but yeah. Here we go, okay? 10 seconds, and we'll display another one, okay? Here it is. Okay, guys, this using the actual service. Finally, what about testing, okay? I'm trying to convince you guys that we need to test. I hope I don't need to convince you that we need to make tests. But when I'm doing tests, I haven't made any tests to the view model so far. Why is that? Because I was trying to get to our end form. Our view models will produce flows of states, of screen states. Trying to test it without reaching the final form will not be very productive. So here you have it. We have our final form. This is a view model which exposes a flow of screen states. Now we can test it. Okay. To test it, we need to be capable of changing the actual implementation of the services. And so you have it. This is exactly what I'm going to show you. I have here an interface, an abstraction, which captures the set of dependencies. Interface dependencies. Now, I have two actual implementations of this. The real one and the one for tests. Okay? For tests, I will have dependencies produced by this implementation. For the actual production code, I will have this. Okay? So I have two different applications, like so. I have the actual application, demos host application, which produces the real dependencies. Okay? And I have the test application, which produces the fake ones. Okay? Both of these implement that interface, dependencies container, okay, which is this, the set of dependencies. Okay? Both of them. So I can do this in our application. In our activities, like this, for example, joke of the activity, we do this. Okay? As dependencies container, regardless of being in test setup or production setup. Okay? And finally, so I can have an application in one case and another application on the other case for the actual production code. I have this demo host application. For the test code, I have this. Okay? Here. Instrumentation test instrumentation runner. I am saying, look, don't use the default runner, use my own. This one. And my own instrumentation test runner will inject the good application, the good test application, like this. Okay? Like this. Whenever someone asks it, give me a new instance of the application, I return an instance of this. Okay? So in tests, I have this application. In production code, I have the other one. And like this, I can have in tests injected fake dependencies, fake implementations, and in production code, the actual real ones. Okay? And that's it. I'm not sure whether this was simple enough or very difficult. There's it's an important topic which presumes that you guys know something about concurrent programming. It's difficult to address all sensibilities, all of this diversity. But well, I will give you links for following this up, okay, to understand it better, and we will continue in our classes to use this, okay? So I see you Thursday or Friday, and my expectation is that you guys move forward towards building application using this approach, okay? The view model has a flow of states. The services have flows of data. Okay, and also the repositories will have flows of data, reactive end-to-end. Whether you implement this in your web API or not, I'm not concerned with that, because at least, you will have this. Where is it? Let me just close, and here it is. At least you will have this. It's not ideal, but this makes sure that our application can be reactive regardless of whether the API is reactive or not. Okay? The polling is made on the service, not on the view model. The view model does not poll. Okay? See you Thursday or Friday, depending on your class section.